All right, let's have a look at the concept of equivalent fractions. What does this mean? Equivalent fractions is, for example, if I have the fraction of a half. We know a half would be a circle divided into two parts. But equivalent, I could also have the circle divided into four parts and shade two of them. It would be exactly the same thing. It's equivalent, but I can write it as 2 out of 4 parts. And then likewise, if I had to divide it into 8 parts, I could shade 4 of them, and it would be equivalent to 2 of 4. So that's 4 of 8 from there. And I can see that this is 50%, 50%, and 50% as well. It's exactly halfway through. So we call these equivalent fractions. In order to go from one equivalent fraction to another equivalent fraction, what we do is we multiply the numerator, which is the top number, and the denominator, which is the bottom number, by the same number. In this case, times 2. And in this case as well, times 2. And we could also jump all the way through from 1 up to 4 and multiply by 4, and likewise at the same time multiply this by 4 as well, creating equivalent fractions from it. Let's have a look at an example of the following. If I've got 2 over 3, is this an equivalent fraction to 12 over 18? So we can go true or false for these ones. And if I've got 4 over 9, is it equivalent to 8 over 15? What about 17 over 40? Is that equivalent to 68 over 160? All right, have a look at those. Think about it for a second. I'll give you a second to think about it, okay? All right, I'm going to go through these and I'll give you another 3. So to go from 2 to 12, I would multiply by 6. To go from 3 to 18, I also multiply by 6, so yeah, that's true. Because they both multiply by the same number. And then B, yeah, so 9 times 2 is 18, which is not going to be 15. So this is going to be 18, and 4 times 2 definitely is 8, but definitely not that. Definitely this one. So this is going to be false. This one I multiply by 4, and I multiply this by 4. 17 times 4. 17 times 2 is 34. 34 times 2 is 68. And 14 times 4 is 160. So that looks good. That looks good too. Let's see if you can check if the next few are equivalent as well. This one's a little bigger. Okay. Feel free to use a calculator to help you. Have a look at B, slightly different. And C. All right, I'll give you a sec to think about it. These are little slightly bigger numbers over here, but the first one we know we can see is multiplying by 2, so definitely true. The next one we're dividing by 2, so it's still true. It's just the opposite way around. The smaller fraction is on the right hand side, and the bigger fraction is on the left hand side. And then 210 over 400 is equal to 105 over 200, divided by 2 by the looks of it, as well. because 105 times 2 is going backwards. So this will also be true. Okay, let's see if we can complete the missing fraction for the following. Okay. All right, so if I've got 1 over 3 is equivalent to something over 9, it's equivalent to 4 over something, which is equivalent to 33 below something, which is equal to 21 over something. Let's suppose you want to find each of these letters, okay? I'm going to call this one A, let's call it C, D, E, and F. What will C equal? What will D equal? What will E equal? And what will F equal for each of these? So to go from 1 to C is the same multiplication that I've got to perform. So to go from 3 to 9, I have to multiply by 3. But to go from here, I would multiply by 3. So C is going to be actually equal to 3 for this one. Yeah. To calculate D, what we got is 1 has to multiply by 4 to get to 4. So 3 has to also multiply by 4. And 3 times 4 is 12. So for the next one, I'm going to go 3 times 11 becomes 33. I'll do the same thing over here and times it by 11. So E will equal 11. And then the last one, because I've known the number at the top, I'll start there. And I'll say, well, 1 goes to 21. I have to multiply by 21. But then 3 has to also multiply by 21. And 3 times 21 is like 21 plus 21 plus 21. I could just add it up. 3 21s is 63. So this would be 63 for that. For F. All right, so those are equivalent fractions. And sometimes it's not given in such a nice way. Sometimes they actually give it to you all confusingly. That's actually, it can go backwards as well. Let's look at one that goes backwards. Suppose I got 100 over 150. And I want to make it to a number that is equivalent to something over 50, which is equivalent to something, let's say 10 over something as well. All right, so for this one here, I want to find x and y. What will x and y be to keep it equal as a fraction? Okay, take a second to try. All right, so the first thing you notice is that 150 is actually the same as 50 times 3. So that means if I'm going to go from 150 to 50, it's going to be divided by 3. So then I would divide this number by 3 as well. All right, but 100 divided by 3 is not a nice number, so maybe this wasn't a good example. But if I had to use a calculator and get it into a fraction form, it would be 33.3, which is actually not something I would use. So this is actually 33.3, which is technically not allowed. We don't want any decimals, okay, in a fraction. Okay. Does the second one look like it will work? I can divide by 10 here, and I can divide this by 10. This one looks good. So 150 divided by 10 would be 15 for this. Okay, that's equivalent fractions in a nutshell, right? Don't forget you can't get a decimal like that.